We're going to take a look at number 19 in section 3.9. We're going to find f prime of x, the derivative of the function f of x equals x raised to the 7x squared power. So be careful here. It is incorrect to say, oh, this is like the power rule. Bring the power 7x squared down in front and then subtract 1 from the power. All right, and then you've got maybe, I don't know, chain rule times the derivative of x, which is just 1. This is not the power rule or a generalized power rule, because in order for it to be the power rule, the exponent has to be a constant. 7x squared is not a constant because it has x. If it was just x to the 7th power, obviously that's power rule, right? Because it's a constant. So if it's a constant, then we can bring that constant down, subtract 1 from the constant, of course, by chain rule, multiplied by the inner function if we have to. So this is power rule. This is incorrect, right? It's also incorrect. We learned in this section about the derivative of the exponential functions. In other words, this is not the natural log of x times x to the 7x squared, or even times, the derivative of the inner function 7x squared 14x. It's not that. It's not exponential function because the base is not constant, right? In the exponential function, the base has to be constant. The exponent is variable. And in that case, the derivative is the natural log of a times a to the f of x times any derivative of f of x using the chain rule. So it's neither one of these rules, right? And so what are we going to do? Well, because both the base and the exponent are functions of x, we have to use logarithmic differentiation. And in that process, we're going to make use of one property of logarithms, and that is the natural log of a raised to any power. And that power can be a variable power or whatever. It doesn't matter. The natural log of a to the n is n times the natural log of a. And that comes again from the property of logarithms, that logarithms are exponents. And when you're raising a base to a power, raising that to another power, right, then you multiply the exponents. So remember, the natural log of a is the exponent on the base e needed to get a, and you're multiplying that exponent by n. So this is the property we're going to use. So what we actually do is we're going to take this function, right, equal f of x equals x to the 7x squared. We're going to take the natural log of both sides of this equation, right? And over here, I can simplify by using this property, because it's x is like the a here, 7x squared is like the n. That power can come down in front. So these are equivalent. And what we've done now is we've made this something we can find the derivative of now. Instead of some function raised to another, some function of x raised to another function of x, we got some function of x times another function of x. And we can take the derivative of that, right, using the product rule. Okay, so what we do now is we take the derivative with respect to x of both sides. As we said here, we're going to use the product rule. Here we've got a chain rule. So the outer function's natural log. What's the derivative of natural log? The outer function is 1 over the inner function f of x times the derivative of the inner function. Okay, so when we're doing the logarithmic differentiation, this is always the case here. And then over here, product rule, take the derivative of 7x squared, bring the 2 down, that's 14x, that's just the power rule, times the natural log of x plus 7x squared, and the derivative of natural log of x is 1 over x. And we can simplify this because 7x squared times 1 over x is just 7x, right? One of the x's divides, cancels out there. And then I want to multiply by f of x both sides, because I want to solve for f prime of x by itself. And so here's my answer. F of x, though, we can replace, right? F of x is indeed x to the 7x squared power. So I've got x to the 7x squared power times all this stuff. Now that would be fine for me. You can simplify this a little bit, because you can look in here and notice, well, hey, for these two terms, there's a common greatest common factor, GCF of what? 14 and 7. I can factor out a 7, and then there's x's. So I can pull out a 7x, leaving what? 14, factor out 7 leaves 2, pulled out an x, natural log of x, and then, of course, 7x, pulling that out leaves a 1. So I can pull that 7x out, and then the 7 can come out in front. And what do we do here when I have x to some power a times x to some power b? What do we do with those exponents? We add them, right? And so 7x squared, x to the first power plus 1. 7x squared plus 1 is the power on x. So this is a more compact and nicer way, I think, to write that out. But there it is. The derivative isn't very pretty looking, but that's how we do logarithmic differentiation on this one. Okay, hope this is helpful.